Hello, my name is Putnam, and this is my video submission for test 2. I'm doing problem 8, and it says you have a pickup. It's decelerating to rest from a speed of 87.5 kilometers per hour in a distance of 125 meters. So the first thing I should do is probably to draw a picture so I can visualize what's going on. Have the truck. It's a terrible truck. And it's traveling at a speed of 87.5 kilometers per hour. And now, since the base unit of speed in metric is meters per second, and this is in kilometers per hour, I should probably convert to meters per second. So this is in kilometers per hour, so I'll just multiply by 1,000 to get the distance in meters. And so this is the distance traveled in 1 hour. So divide by 60 minutes in an hour, divide by 60 seconds in a minute, and you get a speed of 24.305 repeating meters per second. And now it's slowing down to rest in a distance of 125 meters. And the pickup's weight is 875 kilograms. Now, I should also probably write down what I know so I can see if I have any given formulas that can help me find the average force, because in part A it asks for the force of the brakes. So mass is equal to 7 kilograms. Acceleration, we don't know. Initial velocity is equal to 24.305 meters per second. The final velocity will be 0 because it says it decelerates to rest. And and my displacement during this time period is 125 meters. So that's about all I know. And I do have a 1D kinematics equation that gives me acceleration, one of the parts that I need to find the force of the brakes. We know the mass already. And so we need to find acceleration. So the equation we can use is V final squared is equal to V initial squared plus 2 times the acceleration times the displacement. And so now I can just plug and chug because I know all of these except for A, which means I have one equation and one unknown. So 0 squared is going to equal 0. V initial squared, I don't know what that is just yet, so I can just write it like that. 2 times A, and then 125 meters. So now we can try and simplify this by putting it into the calculator. 24.305 squared is equal to 590.733. And it's going to be meters squared seconds per second squared. And now, because we have 0 on this side, we can really just subtract this and get a negative version of that. Like that. And then we can divide by 125 meters to get negative 2A is equal to 4.725 meters per second squared, because this meter cancels out this squared. And now from here we can just divide by negative 2 again to get A is equal to negative 2.362, etc., meters per second squared. And so now we can plug that into this equation to get a force of negative 2,000 negative 2,066.75. And now for part B, it says that instead of braking, the truck hits a concrete wall and is brought to a stop in 2 meters. So all that really changes is one variable. And so we can just do this entire equation all over again. In fact, really, we can just take this equation and swap out this. So negative 2a is equal to 2 meters this time. Here. And then we can divide by 2 meters. We can actually copy paste that, divide by 2, and then get 295.366, etc., meters per second squared, because once again these cancel out. Negative 2a divided by negative 2 to get an average acceleration of negative 147.683 meters per second squared. And then plug that in to force equals mass times acceleration to get an average, to get a force of negative 129,222.8492 newtons. And so finally for part C, it asks for the ratio of the force on the pickup from the concrete to the braking force, which is essentially asking for, in these terms, F2 over F1. And so, really, all we have to do is just plug and chug, because we already know both of these. 8419 divided by negative 2. And we get a number of 62.524, and that makes sense because obviously stopping in a concrete wall is going to be much more violent than simply braking to a rest.
Are you done?
Yeah.